So sorry, I lost the okay. Yes, sir. All right. So next, let's look at the groups UN and SUN. Okay, so these are, so UN consists of n by n complex matrices U such that U dagger U is 1, or in other words, U of dagger is equal to U inverse, okay? These are called unitary matrices. So unitary group. Okay, so that's basically UN.
Hello.
Yeah, hello.
Yeah, sorry to interrupt, sir. I have a quiz from 7. Can I take a leave?
Yeah, of course. Who is this?
Zabir.
Zabir. Okay, I'll give you your attendance.
Yeah, thank you, sir.
Yeah, no worries.
Yeah.
Okay, so this is UN, and if we further restrict, U to have unit determinant, so determinant of U is 1, then we call that SUN, special unitary group of n by n matrices, okay? So U has 2n squared real entries, or n squared complex entries. And you can show that U dagger U equals to 1 gives you n plus n times n minus 1 real conditions, okay? That's pretty easy to show. You just have to observe that U dagger is U inverse. Okay. And the determinant 1, the determinant of U, 1 gives you 1 real condition. Okay. So this means that the dimension of SUN is 2n squared minus n. So this thing minus n squared plus n minus 1. In other words, it's n squared minus 1. Okay, so dimension of SUN is n squared minus 1. Remember that SU2, this was a 3 sphere, so dimension was 3. Okay, so let me just stop here, and we'll have more to say about SUN. It's one of the extremely important groups in physics and mathematics. So before I take any questions, let me just go and give you the attendance, okay? I'm here. Are there any questions? I will post one of the lectures tonight, by the way.
Sir, I have one from lecture 10, that is g theta is equal to 1 plus del theta t. So I didn't get how is this related to the physical reality or something like e to the power theta x is
So
the
yeah,
generator.
so e to the power theta t or I, this is, if theta is not small, this is a finite rotation or finite transformation. But for a very small transformation, when theta is small, we can expand it as a power series, right? And that's a leading term. And then there is going to be higher order terms, right? But if theta is small, we can ignore all these higher order terms. So this is an infinitesimal expansion, if theta is infinitesimal.
And so
Okay.
we took, yes sir, we took alpha, and in the lecture 10 we got theta by 2 in the e to the power I theta by 2.
Yeah, yeah.
So how did the 2 come?
Well, we found that the generators was sigma by 2 for SU2. And that's important because if the rotation is say I theta 3 by 2 times theta, so sigma 3, then as theta goes from 0, if theta changes, through say 2 pi, so theta changes from theta to 2 pi, then this thing goes to e to the power I sigma 3 by 2 theta plus 2 pi. But this is e to the power I sigma 3 by 2 theta times e to the power I sigma 3 2 pi by 2. Okay, so if you look at this, this is actually minus 1 because sigma 3 is then you basically have I sigma 3 by 2 theta. Right, because sigma 3 is 1, 0, 0, minus 1. So if I compute this thing, it's e to the power 2 pi I by 2 sigma 3, which is e to the power pi I sigma 3, which means it's e to the power I pi 0, 0, e to the power minus I pi. But this is minus 1, this is minus 1, so this is minus 1. So we see that the significance of having this factor half, in the generator means that as theta changes by 2 pi, we don't get the same state. If this is acting on some fermion psi, then if you rotate the fermion by 2 pi, we don't get back the same state, but we get back the state times minus 1.
Is it like the physical reality is the real life is changing 360 degree, but the Hilbert space is changing 180 degree?
No, yeah, well, the wave function is changing, not but by a minus sign. So this is a quantum particle is like that. A quantum particle doesn't have to, if you rotate 360 degrees, the quantum particle changes by a minus sign. Even, sorry, I lost the thing. Even in classical, there are classical transformations where if you rotate, in some sense, rotate the system by 360, you don't get back to the same. Configuration, right? This was famously shown by Dirac, and I will post a video on that.